Hey everyone, in this video we're going to be looking at the logarithmic function with base e. This is the natural log as we know it. So it is pronounced, I'm going to write it out, so it's pronounced, so we're not sounding stupid, you know, when we're talking to each other about math, because we never want to sound stupid about math. We pronounce it Ln of x. Okay, it's just saying that it looks like you're reading it out of a dictionary, but you're pronouncing this Ln of x. Or you often hear me say simply the natural, literally you're saying natural log of x. Okay, so both are acceptable ways of pronouncing this, Ln of x or natural log of x. Okay, so taking your advice, we are only looking at the properties in this video, and then in part 2, the second video, we're going to be seeing examples for the properties, taking your advice. So there are some need-to-know properties with the natural log of x. So these are properties that we essentially need to have memorized. Okay, so we're actually going to look at this with two types. We saw in the previous video the common logarithm with base 10, and we're adding to this base e the natural log. Okay, for any logarithm, whether it be common log or ln, the natural log, when you're taking the log or natural log of 1, we will always retrieve 0 from that, and that's with any base. Next, if I take the common log of 10 or the natural log of e, we get 1. And we saw this before. When we take the log of the base number, so here we have base 10, so we're taking log base 10 of 10, log base e of e, we always get 1 from that. It always simplifies to 1. And then we saw, this is kind of a little more advanced than these two. The first two are rather simple to remember. Okay, so I have common log of 10 or natural log of e, both raised to the power of x. We find that simplifying each of these, they will equal whatever our exponent is here. And then the last one, when I raise 10 to the power of log base 10 of x, we get x. So over here, if I were to take e, because that's the base in this logarithm, if I take e and raise it to the natural log of x, it also equals x. Okay? So these are some common properties, some basic properties that we need to know these. I should say, you know, what is natural log of e to the power of x equal? And you should tell me it's equal to x. What is the common log of 10 equal to? You should tell me 1. These are need-to-knows. So some additional properties. Okay, so these properties are really going to expand what we can do with logarithms. The first we titled the product rule. And what the product rule says, if I take the log of any base of a product, so let's say x and y, I can rewrite this as the sum of each individual piece. Okay, saying that again in words. The log of a product is equal to, is equal to the sum of the logs. Okay? Now this actually goes in both directions. So if I have a sum of two logs with the same base, I can rewrite that as one single logarithmic function and the product of those two elements. So it goes in both directions. You can see me put an arrowhead on both sides. Next, so the quotient rule. Switch up the colors here, just adding contrast to what you're seeing. The quotient rule says if I have the logarithmic function and I have a quotient, so that's a fraction, a ratio, that this translates to the difference of the two. So log base b of x subtracting log base b of y. Okay, and notice that the numerator is leads this expression. Okay, so quotient results in subtraction, a product results in addition. And just like before, this goes in both directions. So if I have a difference of two logs, as long as the bases are the same, we can rewrite it as a single log with division. And lastly, yes, I said the last property, we call the power rule. The power rule, and we've technically have already seen this, and it might look familiar to you. If I have the log of some base of an element, it could be an expression or just a single term, raised to an exponent, you would probably tell me that if x was the base, it would equal c, right? That's what we saw up here. Well, how we can rewrite this is this exponent I can bring to the front. So any exponent, we're able to drop down to the front of our logarithm. Now notice it's no longer there as an exponent. And like with all the others, this also goes in the opposite direction. So if I have a if I have a logarithmic function with a term leading it, I can bring that term up as an exponent. Okay? So just to close this video, I'm going to ask you something. And this might seem really random, and you'll see later on why I'm asking you. What's your favorite color? And what's your favorite number? So my favorite color would be blue. I would have to choose blue. And put my little dot here. My favorite number would have to be 310. It's my favorite number, but I can't remember it. 310, 11, 4. Because this is my son's birthday, March 10th, and my daughter's birthday, November 4th. So that would be my favorite number. I just thought I'd share that with you. I don't know. Thought it'd be a good way to end this video. So we have our properties. In the next video, we're going to be focusing on how can we use these properties and those basic properties to actually simplify logarithmic expressions.